Okay, so this course is about CCNA DevNet. As I said, the primary components that we'll be learning are as follows. Python, yes, to answer your questions, you don't need to Python because we'll be learning. Of course, we'll not be able to go to a great depth because of time limitations. So that's the reason I said a lot of self-learning would be required. So we'll be providing you like some reference materials where you can find good tutorials, good extra reading material and so on. The other tool is Ansible and REST APIs. And Git, which is a software version control system. Now, is this enough for you to pass certification? Certainly no. You will have to put some extra effort, you will have to take the blueprint and then follow along. And then see like cover some additional topics as well. Right. Having said that, first I would like to, before getting into the lecture itself, right, I would like to start with helping you to understand the significance of doing this thing, right? Yeah, we'll be learning Python, which is a programming language, Ansible, which is a configuration management tool, REST APIs, which are used for integration, Git for software version control system. But why are we doing all this? The big question that we need to ask ourselves is, why are we doing all this? What is the problem that we are trying to solve? Right? What is the problem which Cisco has conceptualized and has introduced this program called as DevNet, um, via which we are trying to address this big problem, right? So that big problem is network automation, right? Nowadays, I mean, till some time back, majority of the things that are happening on the networking side are kind of manual, and the entire rest of the world has moved on and they have caught up automation. Most of the things are getting automated now, even mundane tasks like scanning your emails, extracting information from your emails automatically and creating tickets based on your data, which is then the emails, and scanning the PDF documents, extracting useful information from the PDF documents. So all such mundane tasks are being automated by tools called as RPA, robotic process automation, right? And anyway, you have the programming world, they're building a big software. So everywhere we have this automation. So why should we be left behind? And in fact, automation is all the more significant in the day-to-day tasks that we will be doing, because we will be doing similar things again and again on multiple devices, device after device, device after device, device after device, and it gets kind of repetitive, kind of boring. And when something is boring, we tend to lose focus and tend to start making mistakes, causing network outages, right? So all these issues are there, which we are trying to solve through this network automation. That is one aspect. The other aspect is the world itself is changing. The networking world itself is changing. It is no more limited to, yeah, there are some devices which are lying on in the data center, to which you connect via SSH and keep doing some configuration. It's no more that case, right? There is something called as cloud that has come up, right? Devices are being hosted on the cloud, and Cisco has come up with a lot of their products, software defined networking, Cisco ACI, Cisco DNS Center, Meraki, etc., etc. These are solutions which Cisco is coming up with to address some problems, right? For example, DNS Center. So how we can maintain data centers uh, 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 at a software level, like by providing a central location through which we can provision devices, add new devices, and create new organizations, create new networks in a logical way, which are mapped back to your real devices and so on. Right now, to be able to scale up ourselves and work with this new products, new applications which Cisco is continuously releasing, we have to upgrade ourselves, which means to be able to automate stuff using, let's say, Cisco DNAG, we need REST APIs. And because something known as REST APIs, what are REST APIs? We'll be getting into that later. And to be able to automate our day-to-day tasks, mundane tasks, we need Python. And to ensure that we configure the network devices in a consistent way, confidently, being able to make the changes confidently without the fear of causing any adverse effects. We need Ansible, right? And all the code that you'll be writing in Python, Ansible, or REST APIs, you need a place where you safely back up your code and maintain different versions of it. Today, you wrote some code, some useful utility, which is version 1.0. Tomorrow, you come, take that, added some useful features to it, that becomes version 2.0 or 1.1. So all that version controlling can be done using Git. So that's how these pieces are linked to each other. They all fall into the bigger puzzle. No sound. Others can hear me? You cannot post questions. Let me open Q&A. Okay, probably I forgot to enable it. For now, you can continue posting your questions on the chat. I'll take a look at the chat again and then. Oh, okay. You're talking about the WhatsApp group. Okay. Yeah. Yes, there is programming knowledge required, which is what we are doing here, right? We'll be learning Python programming language. Okay, yeah, thanks. Thanks for the confirmation. Okay, now let me show, let's take a simple task as simple as configuring a loopback adapter or on a router or creating VLAN on a switch, right? It's just 4-5 commands. You might think, okay, what is the benefit of automating this? Right? Do I really take pain to learn Python, Ansible, which seems to be a programming language, and I don't know. I don't have any development background. I don't have any programming knowledge background. Is it really worth for me to put this extra effort, learn Python, to be able to automate these tasks, which I can do in a jiffy, in a quickly, because it just involves few commands, right? But you might think like that, but imagine you have to configure this. Now you might be part of a small organization, then you move to, as part of your career growth, you move to a larger organization where the number of devices is really huge, really humongous. So you'll have to do this task every day or whenever there is a requirement on all the devices, which means you'll have to manually connect to all these devices via SSH. Keep running these commands. And sorry about that. right? What I'm talking about is this simple 4 or 5 commands that you can use to configure a loopback adapter and a router. Save the configuration and check whether it is successfully created and it is coming up, right? Do this on 1 router, 2 routers, 10 routers, you can do it. If you have to do it on 100 routers, 1000 routers, and again, and today it is loopback 1, tomorrow it will be like loopback, multiple loopback interfaces have to be created, right? Quickly the problem becomes much more bigger. And this is one simple task that I'm talking about. Like this, there are many significant tasks that you'll be doing on a day-to-day basis. And there's a possibility of you making mistakes, right? Suppose you're supposed to configure this on multiple devices, and by mistake, instead of picking this up, you picked up some other command which looks like this, right? You are creating inconsistency on your devices, across your devices within your data center, which is not what you want, right? So that is where automation comes into picture. And why we need automation is in automation we are instructing the machine, which is our computer, laptop or server, to do something which systems are very good at doing, right? They are very good at just taking a set of instructions and continue executing them again and again and again on any number of devices. As long as I'm just able to SSH to those devices are accessible, and I'm able to SSH do a basic SSH connectivity to them, then I'll be able to automate literally anything on those devices. Okay, let's just see this in action before actually going ahead with this thing. And and coming to the topology, I mean, it really doesn't matter whether we pick a very huge topology or very small topology. So I've just taken a small topology with a couple of routers and couple of switches. Whatever we do with these 4 devices, or for that matter, even one or 2 devices, will be the same that we'll be doing with hundreds and thousands of devices, right? So this will be a simple topology. Now you might have questions. Can I use GNS3? Can I use this? Can I use that? And we'll be answering all those in the WhatsApp forums. We would recommend EVNG, and we'll see how that problem can be addressed, right? You will have different personal choices, but it's better each of us stick to the standard tools and standard configuration so that we are all on the same page. Okay, I already have loopback 1 here, so I'll change my details. I'll make this as loopback 2. So this is my configuration commands which I have to go and execute on my routers. I have already written my piece of code, which you'll be kind of shocked if you see. It's not even 10 lines. Right? If I remove blank lines, it's 9 lines. And that too, it is 9 lines because these are device details, the details of the device that we are connecting to. For readability sake, I have put them on. At this point, do not worry what this is all about. Even if it doesn't make any sense to you, that's okay. Right? That is why we are here. This is our first day. We're just seeing some things in action to be able to appreciate the value of what we'll be doing. Right? So the point I'm trying to drive here is for readability sake, I have expanded this into multiple lines. Typically, I can specify this on one line. So it is like 1, 2, 3, 4. 4 lines of code is all I'm writing. With 4 lines of code, I take this configuration command. I can go and apply this configuration on any number of devices. You give me any number of devices, I'll just put them in a file, go on connecting to one after the other, one after the other, one after the other through my code, and keep doing this configuration endlessly, tirelessly, right? With just this 4 lines of code. Okay, so let's see this in action. So what I'm doing here is I'm using some package, as some of you have already mentioned. What packages do we need to know, right? So we'll be getting into those details later, but for now, it's like, yeah, I'm using something called as NetMiko, which will help me to connect to the device. And then I'm specifying my device details here. My device type is Cisco IOS. This is the management IP address, which I can use to interact with the device. This is the username, this is the password, which I'll have to use to connect. Then I'll say, yeah, go connect to the device, get me the device. Once I get the device, send the configuration from a file. Right? This is the name of the file where I have stored my configuration commands. Take this configuration and send it to the device. That's all. I execute it. And it says no module name NetMiko because I am in. Okay, fine. Sorry. That's it. Done. Let's go to the device and check what is happening. So it has detected that from somewhere the configuration is being done on this system by this user called admin. Right. So our program is the culprit. Our program is using the admin username and doing the configuration settings. So looks like it is done. Looks like it is done. Let's go and check our configuration again. Or even we can do this, right? Show interface brief. So our loopback to is configured. It is up and running. Right, in just a matter of a minute. Now the matter of minute is more because we are talking about one device here, but the time remains same or just slightly more for any number of devices. Okay, that is the power of automation that we are seeing here. Okay. Now I'll show you another use of another tool, the second tool that we are talking about, known as Ansible, for a slightly different purpose. For backing up our configuration. Right? This also is one of the important activity, right? Because uh, uh, in case you accidentally end up modifying the configuration on some devices, you need to have the latest configuration backup so that you can take it and apply on the device and get it up and running. So periodically, it's good to keep backing up your configuration. Now, how easily it can be done on multiple number of devices, right? Manually, how would you do it? You'll have to keep giving this command show run on this, and then maybe copy paste somewhere and save it into files and so on, right? But using this tool called as Ansible, we can do it very easily, right? So we'll be defining something known as host, where we'll be putting all these details. Again, at this point, if it may not make any sense to you, it is still fine. I'm mentioning the list of my devices here somewhere in some file. Then from my Ansible code, I will say connect to all the machines which I have mentioned in my list of hosts, right? Go connect to them using something known as iOS command. Give this command show run, because this is the command which will help me to get all the running configuration, right? Once you get this, store it in a temporary location. Then create a folder, my backup folder. Then take that temporary location where you have stored that running configuration, dump it into my backup folder with the device name in a file which is named with the device name. At a very high level, this is what it is, right? Now, this is going to be my backup folder. Let me delete it for now so that, okay. So here my backup folder will get created with the devices to whichever devices are up and running. Like I have 4 devices. As part of my topology, there are 4 devices, 2 are up and running, 2 are down. So whichever are up and running, whichever Ansible can connect to, it will connect to them, get its running configuration and store it in a backup file and put it to some backup storage, some backup folder which we have decided. The other devices which it cannot connect to, simply it says I'm not able to get its configuration because I'm not able to connect to them. Right? All this with about 20 lines of code, including the new lines. Right? So I'll say Ansible. It has extracted the configuration from the devices R1, S1. Now it's trying to connect to R2, S2, which are down. So it throws an error and created my backup folder and backed up my files. Right. If I open my files, I have r1.back, r1 underscore back.txt, s1 underscore back.txt. If I open this file, this is exactly my running configuration from my device. Okay. That is what automation can do at a glance, right? What do you want me to repeat? Okay, now that we have seen, let me take a few questions. Okay, the config part. How is Python config platform is made to connect to this Cisco device? We'll be getting into the details, right? We'll be using a package where we have we'll be using some inbuilt packages known as NetMiko. We just need to provide details. What is the IP address of my device? What is the username? What is the password? What is its type? Internally, it will figure out how to connect to the device, as long as it is pingable and SSH is enabled. Which one to use between NetMiko and Paramiko? Yes, we'll be discussing both. And after we discuss both, right, you will be in a position to decide which one to use, because we'll be showing both what exactly each one can do, and what is difference and what is advantage of one over the other. Yeah. I've not spoken about anything about what you have seen there, so you might be a little confused. What am I doing? Am I working on a virtual machine? Am I working on something else? But that's okay. We'll be getting into the details. I'll be explaining these concepts, whatever I've used just now. Oh, yes, you'll be getting the files that we'll be developing together. But at the same time, no, it's been a while, and you'll be getting recording of it, so it's fine. Yeah, Shashank, is it possible to post? Because if I, okay, let me, yeah, you can unmute yourself now and then ask.
Thank you, Nagaraj. Hope I'm audible to you.
Yeah.
Hello. Yeah. So the question is like I was going through some stuff on internet. I was working on Napalm, and I found like if you configure multiple, you have configured dictionary, right? And provided the parameters, key value pairs for the router. You can, open a file and, import the IP addresses while you are using NetMiko or you are doing a telnet. How about, if you are using Napalm and is it feasible in Napalm to do that?
Well, I would say this discussion, let's keep it offline, because many of them don't even know what we are talking about. So it's not fair on their part to take up this discussion here, and right, you have some prior knowledge. So if yeah, I can discuss with you,
I
but
totally agree.
yeah. So I got
But
your question. So I'll let you know.
Thank you.
Okay, thanks. Okay, no problem. Okay, now that you have seen what automation can do, let's get started. Yes, someone asked for what are the topics that are important for network automation in Python. Yes, we'll be sending. I mean, there's a blueprint which we have prepared. If it's not already shared with you, we'll be sharing with you what will be the topics and subtopics that we'll be covering as part of this. And let's get into that. Yeah, it's here, right? What we'll be covering. This top table of contents, and yeah, you'll be getting this material also. Okay. I put this because someone asked, okay, we need to have, but before that, right? So before that, like, what is DevNet all about? Why Cisco has introduced this? Right? Basically, Cisco is expecting network engineers to scale up and gain some development skills so that they are coming up with new products which require a lot of applications, a lot of integrations to be built. So they're programmers, the existing programmers, they're not familiar with the networking concepts. So they'll not be able to do justification if they are brought in to develop these applications. So instead, if the network engineers can upgrade themselves and become somewhat like programmers, then it will do a great benefit for both the companies as well as the individuals will benefit from this, right? So that is the primary objective of this DevNet program. It is Cisco's developer program. It is meant for developers, and it is meant to help developers and IT professionals. It is meant for facilitating to write applications and integrations with Cisco platforms, products, and APIs. And it's a kind of bridge between the software engineering world and the networking world, right? Till now, the networking was like a support team where the software engineers are developing some code for which is required for their product. Whenever they hit any network connectivity issues with the network or the servers, they're not able to reach the servers, or they need any new servers to be added, they just used to approach the networking team, and then network team would use to resolve. But now things have changed. Network team themselves are coming into the focus, where they will have to take up projects, large projects, where they build big networks using these new age technologies like software defined networking, and then build applications using Cisco's products, platforms, APIs. So that is a gap that I'm talking about, which this DevNet program tries to address. It is trying to bring best of both worlds, right? Network engineers with programming background, with programming knowledge, or programmers with networking knowledge. So they felt easier would be, yeah, network engineers if they learn programming, right? Because they realized programmers learning networking concepts to an expert level would take ages. And here, the kind of applications that we are talking about, they require decent programming skills, not very expert level, right? But the wealth of knowledge that you have on the networking side will be of great help and importance if you learn programming rather than the other way around. Okay. So ultimately, the fact of the matter is, yes, we'll be doing some form of development. Development means we'll be writing code, which is not really new for us, because all of you would be familiar with something known as shell scripting on the Linux, that the simple scripts that we develop for automating some of our tasks. even if you have not done that, right? The commands that you, if you are a pure networking guy who work with only with network devices, still the list of commands that you give on the network CLI, network device CLI, are nothing but programmatic statements, right? You say EN, how your device is taking you into enable mode, which means the EN is a utility which is written in the network operating system, and the moment you say EN, it understands, the networking operating system understands that yes, you are trying to get into enable mode. It takes you into enable mode, right? So only difference is when you SSH to this your network device and start giving commands one by one, you are interacting with the system in an interactive mode, which means you give one command and the device responds. You give second command, device responds. You give third command, the device responds. Right? That is one way of interacting with the device. The other way of interacting with the device is you put all your commands in a file, just like how we have done in case of Python. I put all my configuration commands in a file. Go and give all these commands to the device at once. That is non-interactive way of interacting with the device, which means programmatic way, right? You write a small program with where you put all your commands and then go and give this command at once to the underlying system. Okay, that is what we'll be doing. We'll be writing some programs which will contain certain instructions. The instructions that we have been using so far are core network configuration commands. Now we'll be writing some programmatic statements, some other statements, lines of code, which will help us to carry these configuration commands to the devices, to multiple devices, wherever they are sitting across the globe. Now, to be able to do that, some of you have asked, right, what is it that I was using? The tool that I was using is known as IDE, right? This is known as IDE, Integrated Development Environment, right? Development environment, because it is helping me to develop this kind of code, Python, Ansible, etc., etc. Integrated because I'm writing code as well as executing code all in the same place without going out of this, right? So that's the meaning of integrated development environment. Now, there's a flashy term which is given to a simple text editor, right? A simple text editor like Notepad. I can put the same commands, I can save them, and I can execute them. But a humble guy like Notepad will not be able to help me to, like, suppose I put those 4 or 5 lines of code here, Python code, which I've shown. Right, I can save this as a .py file, Python file, but the problem is I'll not be able to execute this code right from here. Of course, that's not a big hurdle. I can always go to the underlying command line and execute it from there. But the advantage with this IDE is it will help you to write code, execute code without going out of this environment. That's why we call this as integrated development environment. That is one aspect of it. The other aspect of it, you see this nice coloring, right? These brackets are in yellow color. This special words are in some purple color. So it distinguishes what you are trying to do, and then shows different things in different color coding, so that if you make any mistake, right, immediately you will come to know. Right? Suppose here I'm trying to import something. I'm trying to borrow something. So I'm supposed to say import here. Suppose I made a spelling mistake and forgot to type T. You see, it is in white. So by looking at this, I know, oh, something is wrong here. And then I'll go and check, yeah, what is the mistake that I made? It is supposed to be import and not import. Yeah, like this. And see on the execution side also, you get this nice colored output. Of course, this colored output is coming from Ansible and not from this IDE. That also we'll be talking about. Okay, so the things that we will be doing will require something known as a development environment, right? A typical development environment looks like this. So these are some of the tools that you will be needing if you intend to become a kind of developer, right? What you see here are operating systems: Mac, Windows, Linux. So basically, you need a laptop with one of these operating systems, and you need a terminal from where you can start giving commands, and you need a couple of programming terminal, or if it's a Linux system, you need Bash, and you need a couple of programming languages. This is Python. This is something known as JavaScript. And you need a kind of, if you still want to build more complex front-end based applications, this is known as React, right? You don't have to worry about these things. I spoke about APIs, right? To work with APIs, you need this guy here, the man who is trying to fly like a rocket. He's called as Postman, right? So we need Postman, and we need this guy here called as Docker, which will help us to whatever we have built. He will help us to nicely package it into something called as a container, right? So typically, these are some of the tools. Like there are many other tools which we'll be using. There are a lot of plugins that we'll be using. There are a lot of packages that we'll be using. What are plugins? What are packages? All that we'll be covering. You don't have to worry at this point of time. As someone was asking, what all plugins do I need to install in my VS Code? Right? We'll be covering that. In fact, VS Code is smart enough. You start working with it, it will keep prompting you. Do you want me to install this? Do you want me to install that? And to answer your question, we don't need much. We just, I mean, you're working with Python, so you need a Python interpreter, Python plugin. If you're working with, let's say, a software version control like Git, we'll be needing that. If you're working with Docker, we'll be needing its plugin. Anything that we are writing code, there is an underlying plugin in VS Code. Okay, so typically we will be needing some tools which will make our job easier. All those tools, when we install them on a server, that becomes our development environment, right? You'll be getting one VM image with all the with most of the prerequisite software installed, right? Which looks how to integrate all of this. Yes, that is the goal of this program. How to show you how to integrate all of this. This lab instance is practice environment. Yes, so we have not yet. I mean, we saw the EVE-NG lab, which consists of devices, and I'm just starting up the machine, which is kind of your lab environment. Can we say it is a DevOps specific to Cisco? It is not just DevOps, it is more. Yeah, it is DevOps typically takes care of the operations part of it. Here we are also doing we'll also be doing the development. Yes, so it is a complete package. Yes, we'll be doing lab activities, because without that, we'll not be able to retain what we are learning. System requirements are very basic because I'll show you what I've given. It's 8 GB RAM. I mean, basically we need a VM, VMware player or VMware workstation if you have. I have given this machine 8 GB RAM and 4 processors and 50 GB hard disk. Of course, this will contain only your development tools. If you need EVE-NG also, that will require some additional this thing. So this is my EVE-NG because I have some extra RAM, so I gave it 16 GB. If not, like, yeah, whatever little we can give it. Only thing is we'll on and off the devices based on the resources we have. Yes, you can use G3, etc., anything, as long as your devices support SSH and you are able to SSH to them from outside, from the machine, from where you plan to, on which you plan to do these activities. All you need is you should be able to SSH to your devices. Doesn't matter whether those devices are on your Cisco Virl or GNS3 or EVE-NG. If you already have that setup, well and good. Okay, so this is my. So you'll be logging in as student. Okay. So basically we'll be getting something like this. Okay, with most of the stuff pre-installed. So that takes care of your development environment. So you'll have your development environment ready so that you can focus on your learning rather than figuring out, okay, how do I set up, how do I set this up, how do I set that up. Okay, OS you'll have, shells and command lines you'll have, source control system will also be installed, Git will also be installed, programming languages will be installed, Python will be installed, Ansible will be installed, and your Postman will be available. Okay. Yes, they are pre-configured. Okay. So far the questions I've been seeing are like out of the topics are we are thinking too advanced into the future and asking questions. So are there any questions based on what we have discussed so far so that I can address that? And all the questions are about, will I be getting this? Will I be getting that? Yes, you'll be getting everything. And Router images, they are available on internet. Some good souls have put all the images in some drive location. So it's out in the open. It's out open in the, it's open in the, there on the internet. So you'll be able to just search, do a simple Google search and be able to get them. If not, I think I should have that link somewhere. I can help you out with that. This is going to be a daily class. Yes, it is a daily class, 5 days a week, same time, 8 to 10 p.m. IST. And then, yeah, you will be needing EVNG community. Is good enough. How the training style will go. What I'm planning is, I mean, it all depends on your cooperation, right? How this training will go. What I'm planning is like we'll have 1 hour, 1.5 hours this theory, and parallelly also you can start doing the hands-on with me. And last half an hour we'll keep exclusively for any help you might be needing with the hands-on, any errors you might be getting to resolve those errors, any questions that I need to address, and so on. That's the very purpose of this. You don't need a programming background because we are learning from the basics. We share the lab workbook. Yes, we'll be sharing it. It will take some time. DevNet is useful in which environment, client side or service? Wherever you have a problem to solve, right? If you have a problem to solve at the client end, you can apply the DevNet concepts to the client end. If you have a problem to solve internally at the service provider end, you can do that. Yes, you will get a basic topology, whatever I've shown you, and initial, may not be initial setup. We'll get a, yeah, we'll get a WAV file. Okay. Shall we start? We'll let you know. Like, I mean, if you say for how long, it's like how many days, we'll let you know. Okay. Yeah. So now you know, we have seen a lot of stuff. Finally, we decided, okay, we need to learn at least one programming language, right? That should be the conclusion you should have come to by now, right? Looks like, yes, I might be required to do some programming. So, and I don't have any programming knowledge so far. As someone said, you've been working 7 years, 8 years with some of the technologies. So yes, at least one programming language you should know as part of Cisco DevNet program. And the best programming language for learning would be Python. Why? We'll come to that in a minute. But before that, you might be hearing this shell scripting, right? Linux shell scripting. And then there are this programming languages, Perl, Python, Java, C, C#, .NET, etc., etc. So first confusion that we need to clear is, okay, what is a scripting language? What is a programming language, right? Why this shell scripting is called as a scripting language, and why the other things are called as programming language, right? So basically in coding, right, there are these two styles, scripting and programming. Scripting, the main difference is this. Scripting is low level, which means using the scripting languages like shell scripting, you will be interacting with the underlying operating system to do some tasks at the operating system level. Whereas in programming languages, it is like little high level. You will not be going down to the level of working with operating system. You will leave all that to the internal stuff. You'll be focusing more on building some useful stuff, some UI, some applications, some web pages, and so on. Okay. And scripting languages are not like general purpose, right? For example, by general purpose, I mean, like let's say you want to build a game, you want to build a mobile app, you want to build a banking application, you want to build a healthcare application. That is general purpose, right? I cannot use my Linux shell scripting to build a to build a game, to build a web page, right? Whereas I can use high-level programming language, general purpose programming languages like Java, JavaScript, Python, etc., to build those kind of applications. Scripting languages are ideal for automating your simple tasks, day-to-day tasks that you want to do. Like as Linux administrators, let's say people are approaching them to gain access, like ACL modifications, providing access, creating some folders, shared folders, and providing access on the file servers, and so on, right? Like creating users, giving them permissions, changing passwords. These are the tasks that Linux admins will typically be doing. So shell scripting are good for those tasks, and they are like we call them as they are not modular or reusable. Of course, you can reuse them. If you write one script, tomorrow if you have to do similar task, you can reuse that. But you cannot reuse it for, let's say you have a slightly different task to be done. You cannot reuse that because you would have written that script specifically for doing one specific task. If the task slightly changes, you'll have to go tweak that script and then do it. Whereas in programming languages, right, we think of all these possibilities. While writing a program, we think, okay, what all different situations this program might be used. Accordingly, we come up with logic and then take care of all those different possible scenarios in which this program will be used and take care of it, so that this program can be used for purpose A, purpose B, purpose C, and so on. Okay. Now, there is something known as interpreted and compiled. That is just the instructions that you give are typically in a English-like language, right? If you have seen, even for that matter, the network commands that you see. Right? You're saying interface loop back to IP address this end, write configuration, show IP interface brief. And these are like your English-like commands. How on earth your underlying Cisco device is going to understand this English, right? Because these devices, these electronic devices, switches, routers, laptops, PCs, servers, they understand only one thing. What is that one thing? Binary, 0 and 1. That is the only thing that they understand. Zeros and ones. Anything that they want to do, they will do only in zeros and ones. Right? Now, for our sake, obviously, I cannot write all these commands in zeros and ones. Right? It doesn't. I mean, I can write, but it doesn't make much sense to do that. So, to make my job easier, I have invented commands like this, which look like English. But as I said, like I understand only this. System understands only zeros and ones. So there's a gap, right, between what I understand, what I write, versus what the system understands and what the system expects. We need to fill this gap, right? Which means we need some third party who is sitting in between me and my system, who is taking English commands from me and converting them into zeros and ones, which can be understood by my system. That third party guy is your either interpreter or compiler, right? interpreters and compilers are nothing but some software, some applications which sits between the program that you write and the system on which it has to execute, right? For example, these commands need to go and get executed on your Cisco router. So who is taking these and converting it? That is your Cisco IOS. Right? Cisco IOS, Cisco operating system is doing the job of converting these user-friendly commands into the zeros and ones which your Cisco routers can understand. Same way, this Ansible, the Python code that I have written here, how it is going and executing on my system and doing all that I ask it to do. Internally, there's a guy called as interpreter, Python interpreter, who takes these lines of code, translates them, right? Translates them into machine understandable code, converts it into zeros and ones and executes them there. Please do not draw anything on the screen. Okay, so far so good. What do you understand? What do you mean by how you actually write code and how it actually goes and gets executed on the target systems? So there's a third person sitting in between who is helping you to translate things from one to the other. Okay, now there are two types of translators. Interpreter and pilot. Interpreter is like, think of this scenario, like there's a Japanese official or Japanese politician who comes to India. They don't know English. They even if they know English, they refuse to speak in English. They want to interact only in their language. And obviously we don't know Japanese. So what do? We call an interpreter who can interpret from one language to the other. Right? So the interpreter, first the Japanese guy speaks something, interpreter immediately translate that one line into English or Hindi that we can understand and tells us. Then our guy responds in English or Hindi. Interpreter again takes it and converts it into Japanese and tells that guy. So interpretation happens line by line, right? Interpretation happens line by line. Same thing happens here also. Your Python interpreter first takes this line, sees that, oh, okay, I'm trying to do something here. It goes and does that. Then sees this line, it goes and does this. Then sees this line, goes and does this task. Finally sees this line, goes and does this task. Okay, it goes line by line and executes the task. There are other type of programs known as compilers. What these compilers do is they go through your entire code that you have written. Right? For example, I have written this code. They go through this entire code and they check for any errors. Have you made any like some spelling? Have you missed this comma? These are known as syntax errors. Because ideally this comma is supposed to be there. Right? If I miss this comma, my Python will not tell, because Python will first start with this. There is no problem with this. Then it comes to this line. There's a problem with this line. So it reports this error when it actually starts executing it. Whereas compiler first goes through your entire code, sees whether it is proper. If it is proper, it converts it into an intermediary file, which will then be converted into machine language. Okay, that's how compilers work. You can think of this compilation process as a music composer, right? Who is or orchestra conductor, right, who has people, artists in front of him with string instruments, percussion instruments, wind instruments, and so on. Each piece, each of them have their piece to play. Right? When they play that, this music composer puts all these pieces together and converts it into nice song, nice piece of music. Someone is trying to be very childish, so this is not the forum to be childish. People are here to learn, and they are serious about their careers. Okay. Any question on what is interpretation, compilation? Well, you can do network automation in any language, but it is very difficult. Python is the best language and easy because lot of packages have already been developed in Python. You'll get a recording. Yeah, this thing. There's nothing like which is better. It's like they have been. It's like they are predefined. I mean, for example, like Python is interpreted. Java, for instance, is compiled, right? So now we know that we have to use Python for network automation. We cannot use Java. So you cannot really choose. Why I have explained this is just since we are learning Python, we'll keep seeing that Python is interpreted. Python is interpreted. So you should know what do you mean by interpretation and what is the other alternative. So that's what we have explained. Both of them have their own advantages and disadvantages. Right? Compilation can catch errors upfront, but that makes them little slow. Interpretation is fast, that makes them prone to errors. Errors will be caught only when things start executing. In our case, since we are using Python, it is interpreted. So there's an interpreter which takes your Python commands and converts them into machine understandable language. Config format in iOS is XML. Python does not convert it into XML. XML is one way of providing your configuration, right? Storing your configuration. XML is just a file format. The configuration that you put is for storing this thing. But actually, yeah. So you can view the configuration in different formats, right? Because you are saying format, it is formatting you in XML and giving. You say JSON, it shows you in JSON format. So that is just for our viewing purpose. But ultimately, when Python goes and interacts with your devices, it goes as if how you would go and interact with the device. You SSH to the device, you read CLI, you read shell, you start giving commands at the shell. So when you are giving commands at the shell, you're not giving them in Excel, right? You are giving them as commands. That's what Python will do. Python will go to the network device, it will SSH into it, it will go to the shell, it starts giving commands. Okay. Not really, it's not just passing the strings. So yeah, ultimately that's what it is doing. It is taking the commands which you are giving there and going and executing on the device. Okay. Now some fundamental concepts of programming. When you say you're writing a program, all you are doing is you are giving certain instructions to the computer to go and execute. And as part of program, what you are doing is you are processing some data. Right? You have some data which is in raw form. You convert that into your program. You write a set of instructions to convert that data into some usable format. For example, you have a banking application, right? The raw data that you give, let's say you want to transfer some money from your account to your father's account, right? So the data that you get is two account numbers, from account number to account number, and the amount, how much money has to be transferred, and some other details, which mode you want to use, whether you want to do it now, later, any comments that you want to add, all those are like optional. The core details that you need is, yeah, from which bank account to which bank account, how much money should be transferred. So that is the raw data which this program known as, let's say, a balance transfer program is doing. If you further break it down and see, account number is nothing but a series of numbers, right? Money is just numbers. Let's say you're sending $500, so it's just 500, right? But for the program, these numbers, for us, they are just numbers. For the program, or is the other way, for us they are like account number and amount. For the underlying program, they are just numbers. It takes these numbers and says that, okay, I need to connect to my bank server. Using this account number, I need to get the details, whether there is a sufficient balance in this bank account for this transaction to be completed, for this transfer to be completed, right? And it finally goes and does the job. So what is happening in programming is you have a set of instructions which you are giving to your program through your program. You are putting some instructions in your program. Those instructions are taken and they have some data on which they work on. They go and get executed, right? Now, in this case, what are the instructions and what is the data? The router details, right? What is the operating system? What is the IP address? What is the username, password? And what are the commands, config commands? Again, here, the IP addresses. These are all data, right? The instructions themselves are, okay, take this data, go and connect to the router, which is represented by this data, which means there is a Cisco IOS router sitting somewhere on your network with this management IP address, with this username and password. Go and connect to that guy. Once you connect that, once you connect to that router, come here again, go and read this file. Inside this file, you'll find some config commands. Go and execute these config commands on that device. So that is what we have given instructions in these 4 lines, right? And this is the data. So using this data, it takes this config commands, goes and executes it. What is the result? The desired configuration has been made on your target device, the Cisco router, as we saw. Okay, that is what you will be doing in programs. Program is nothing but a set of instructions which takes some raw data, and using these instructions, it processes that. Okay, a program is a set of instructions given to computer to perform specific operation using some data. Can we say interpreter and compiler is based? Yes, it is based on the programming language. And once you cross this level of fundamentals, right, you will not really care what is happening, because you write code, you just execute, things happen. How things happen internally, we will stop caring after a while. Yes, sir. When we say Python, yes, we'll be learning all the things that come with that. Data structures are very much part of Python. We'll be learning them as well. Okay. Now, some facts, what exactly is Python, who has created it, when it was created, how it became to be so popular that it is today, right? So there's a guy called Guido van Rossum who created it in 1991. It started as a scripting language, right? Many of you might not know, Python started as a scripting language, which means it was very basic. All we could do was write some basic Python scripts for automating our day-to-day tasks. And then slowly it became a programming language, right? We could write some simple programming languages. But where it really, things have really changed for Python is, if you see the code, right, it's very easy to read this code, and it is very readable. From something, do something, from something, import something. Once you connect to this device, send config from file. So they are almost like your English sentences, right? Because of this, people from other fields, right, just like how you and me are struggling now. Okay, I need to learn Python, and if at all I have to learn some programming language, which programming language should I learn? You go look at C, C#, you go look at Java, you get scared by the kind of restrictions they have, the kind of syntax that you have to learn. Then you come and see Python. Oh, looks like of all this, Python seems to be somewhat easy for me to understand and learn. That's what the initial network experts thought. Okay, I need to convert my expertise, network expertise, into programming. And I need to write some predefined libraries so that others do not have to reinvent the wheel. I have invented a wheel. I want to pass on this wheel to others so that they don't reinvent the wheel. Rather, they use the wheel, go and build beautiful things on top of that. So they decided to convert their networking knowledge into programming modules. Then they started looking around. They also had the same issue. They would have gone to Java, C, C++, which are prevalent at that time. They would have found, oh, okay, these are very difficult for me to learn. Even if I learn, it will be very difficult for other network engineers to learn. So they decided, okay, Python seems to be relatively easy to understand and learn. So let's start writing network modules in Python. So that's how they ended up writing all these utilities. For example, Paramiko, Netmiko in Python. So in Java, there is no Netmiko package or its equivalent, which will help you to go and connect to a device, remote device, and then start executing your commands. Why? Because the guy who was writing Netmiko, he felt Python, he could pick up Python easily compared to Java. So he started writing this utility in Python. That's how Python became so popular, right? People, all the networking guys started writing their own modules. So for example, someone mentioned about Napalm. Napalm is another package which can be used to connect to multiple third-party devices. So the NAPM creators also thought the same thing. And they ended up creating a NAPM package in Python. So that's how we ended up with this huge number of packages in Python. All lectures are theoretic? No, they are going to be hands-on. In the initial stages, we cannot get rid of theory. If you want to jump into hands-on right away, it will not make much sense. I can start showing you the code, but it will not make much sense to you, right? First, we have to learn some theoretic concepts before we get into the hands-on. Okay. Okay, I guess we'll stop here. We have about 15 minutes left. So we'll I'll unmute. I'll let you unmute. You can ask any questions. Oh yeah, you can unmute yourselves. Yeah, you can unmute yourselves now. If you feel comfortable typing it, type it. If you feel comfortable asking it, ask it.
Yeah, can you please suggest the book which we should refer for that CCNA DevNet?
Best is CCNA reference guides. So the blueprint document is there and their guide is there. But I'm not sure if it is free or you need to buy it from Cisco Press. But there's a document specifically for CCNA DevNet.
Okay.
Hi, how can we access the notes files there? Thank you.
The notes which I'm showing,
Yes,
I'll be sharing it based on session by session basis, whatever we have covered, I'll be extracting it into a, let's say, PDF, and I'll be sharing it with you so that you can use that as a reference guide.
thank you.
Hey.
Can we get the image for the VMware that you showed that all the things required are pre-installed?
Yes, so we are working on providing it to you. So we'll do it.
Okay, thank you.
Hey, Nagaraj is Sain here.
Yeah,
Just asking that we'll run 2 sessions parallelly, EVNG for the nodes and then VM for the image for the Linux as well, right?
Yes, so you see, in the initial stages when we are practicing the regular Python commands, we'll not be straight away interacting with the network devices, right? That comes towards the end when we talk about packages, Netpeople, and trying out package. Till then, we'll be just learning different programming concepts. So in the initial stages, you would not be needing EVNG. Only when we are doing something with the network devices, you'll be needing both of them running in parallel.
Cool, thanks.
And at the max, it's like you can just have 1 or 2 devices up and running, and that should be good enough to practice.
Because the example you showed, you are running it from the Visual Studio Code. I'm believing you have these routers on your network in the right now, right? Like you're not running it in from a VM. You're connected to these devices when you launched the first demo.
Yeah, so EVNG is also running in my in a VM in my workstation. And this is my local IP. And this is where the devices are running.
Uh,
But
Nagraj?
it really doesn't matter as long as you're able to reach them via SSH, wherever they are, in whichever network they are, we are good. Yes, someone was asking.
Yeah, Nagraj, Shashank this side.
Yeah.
I just need to ask about two other VMs that are running parallel to EVNG. So is like we can have Docker in this EVNG as well. So that we can call the Docker with the specific functionality in EVNG itself. Why is it like what purpose these VMs are solving?
You mean to say you want to run EVNG in a Docker?
No. The newer, apart from community version, we have other version of EVNG
Yeah.
in which Dockers are there, and these images can be imported in that EVNG itself.
Okay.
Is it solving
you're
the
saying-
same purpose?
You're saying the device images are available as Docker images,
Correct.
which can be imported into fine. Fine, that is also fine. I mean, as you're saying, they're not available in community version, which means you'll have to purchase them.
By that, yeah. So,
So
just need to ask: are these two VMs which are running Octalab environment and DevNet Lab environment, are they fulfilling the same thing?
No. My EVNG has images deployed. These images deployed.
Correct. Okay.
And I'm able to start them and work with them. So my EVNG is self-contained. EVNG, even if I stop the other VMs have nothing to do with EVNG. Right? EVNG is a standalone. It has these images deployed within EVNG itself, and I can start these devices, SSH to them, and then start working with them.
Okay, I got that point. But my question is, what is the purpose of other two VMs that are running?
Other VM is my development environment on which we have Python, Ansible, IDEs, Postman, all other tools are installed on them.
Okay, are they connecting
so
to
from
EVNG?
there you will push the program to this EVNG devices, right?
Yes, from the development environment.
Okay. And both of them are on same VNet management, like must be on your LAN network, right? Both of them.
As I said,
that is how you are connected.
Yeah, as I said, SSH. We should be able to SSH to network devices.
Yeah, reachability must be there, of course.
Yes. So if I can SSH to a network device, I can push my Python code and get the things done on the network devices.
Thank you so much.
Ravi, could you please list off the Python topics we need to be well versed from network standpoint of view, because Python is very vast and it differs. So
that's why this program has been specially carved out to cover bare essentials which are required for you to master these networking topics. So as you said, it's very vast. We'll not be able to complete them. And there are so many packages. For example, like you have AI/ML packages which we don't need, right? So we'll be specifically focusing on networking packages.
Okay, such as regex and all, right?
Regex, if it requires, if a regular expression processing needs to be done, we'll cover it.
Makes sense. Thank you.
Yeah.
Hi, Ravi.
Even GNS3 will work with this. Yes, as long as your devices, GNS3 devices are reachable via SSH. Yes.
Hi, Ravi. Ashish here.
Hi. Yeah, Ashish.
So, Ravi, I just want to ask, my laptop is having a RAM of 8 GB. Okay. So,
How much?
if, yeah, 8 GB.
Okay, okay.
So now the VM package which you will be sharing with us, I think we need to order it 8 GB, right? So ideally, which is not possible on my laptop, right?
Mhm.
So is there another way like to perform these labs?
No, I mean, you can allocate 4 GB RAM also.
Mhm.
It will be slightly slow, but it will still run.
But if I also have to like launch UNG, so I also need some space, right?
Yeah, the other way is you need to get another laptop.
Yeah, because why I was asking, like, is there any other way where we can like perform this image on cloud?
Uh, There
Just
might be,
querying
but
that.
but nobody will give these things for free of cost, right?
Yeah, okay.
That is the problem.
Okay.
We'll see.
So,
We'll discuss internally and then see if there is a way we can address this problem.
yeah. Because why I'm asking, maybe there are some students maybe who face this issue which I am facing right now. So that's why I just thought to ask.
Okay.
Thank you.
Yeah. Yeah, someone has answered your question on Google Cloud Platform. You can set up a lab for free with a new account, but it will have certain limitations. These images are independent of the underlying operating system. I mean, there's a EVG image for Apple, right? DMG, I guess it's not DMG package. As long as if you're, I mean, for Apple, you have VMware Workstation, you have EVG. Once you install VMware Workstation, the image which I give will go and sit inside your workstation. So it doesn't matter whether it is Linux or Mac. Not yet, we'll be sharing. We have not yet shared, we'll be sharing it. Same way, EVG is also available for Mac. Once you install that, the network images can be deployed onto your image. Thank you. Thanks, everyone. If no other questions, we'll wind up and meet you same time tomorrow.